On our next examples, we're going to actually graph. I think we're going to use Desmos to graph these. We're going to graph the system. We're going to determine if it has no solution, one solution, or infinitely many solutions. If it has a solution, we're going to name it. So we're going to graph y equals 2x plus 3. So let's go into Desmos. And we'll type in y equals 2x plus 3. You should be able to graph this by hand. We're just using Desmos because it's quicker. It has a y-intercept of 3 and it has a slope of 2. The graph is going up. Now click on line 2 and we'll type in our second equation, which is 8x minus 4y equals negative 12. Notice, whoops, I got 2 negatives in there. Get rid of that 1. What happened here? This is what we're talking about, a dependent system. If we click on the blue line, so it goes away, there's a red line. If I click on it again, it comes back. So notice this is a dependent system. You can turn your graphs on and off by clicking on the number to the left. So this system, we're going to say, is dependent. It has infinite solutions. I guess it didn't ask us to classify it, but we'll put down infinite solutions instead. Now let's take a look at example 4. We're going to do x minus 2y equals 4. I'm just going to click on the x's and get rid of it. So we'll say x minus 2y equals 4. And my other equation is x minus 2y. Whoops, got x plus 2y there. X minus 2y equals negative 2. Probably could have guessed this one without graphing it because those lines are the same except for the constant term, so that makes them parallel. They have the same slope. So this one has no solution. So you just graph them and see if they intersect. You would name that point. If they don't intersect, it's no solution. Now in example 5, probably the hardest part of this problem is writing the equations. It says Nareesh rode 20 miles last week and plans to ride 35 miles per week. Diego rode 50 miles last week and plans to ride 25 miles per week. Predict the week in which Nareesh and Diego will have ridden the same number of miles. So here's what I'm going to do. My miles are my dependent variable. So I'm going to let y be the total miles ridden. And I'm going to let x be the number of weeks. I like x and y because we're graphing. Let's write an equation for Nareesh. Hopefully I'm saying that right, or Nareesh. So he rode, or she, I guess I don't know the gender, 20 miles last week. So we're going to say y equals 20. And then plans to ride 35 miles every week, so plus 35x. And then we'll do the same thing for Diego. Well, when I mean the same thing, we'll write an equation for Diego. So the total numbers of Diego, well, Diego rode 50 miles last week, but then plans to ride 25 miles per week after that. So we're going to graph these two, 20 plus 35x. I don't really think you really need the y equals, but I'm going to put it in there anyway, plus 35x, x, not parentheses, And then Nareesh is going to be 50 plus 25x. So y equals 50 plus 25x. Now, you see the problem already, hopefully, that these two lines, you can't even see the y-intercept. So we're going to scrunch our graph in so I can see my y-intercept. And then I think I'll spread it apart here. And the nice thing, if you click on your graph, it will tell you where they cross at. So after 3 weeks, because x is the number of weeks, each will have driven 125 miles. There you have it.